Welcome back to additive manufacturing and 3D printing using Ansys SpaceClaim. This is week 3, where we'll be covering and discussing more advanced 3D modeling tools. In the previous week, in week 2, what we covered or what we learned was that you can use the pull tool on any enclosed area of a sketch. So if your sketch has multiple surface areas, you can use the pull tool on any one of that enclosed area or on multiple of those enclosed areas using a multiple area selection using the Control and Shift keys with clicking. We also learned that you can define sketch planes on the surface of your 3D model by clicking on sketch mode and clicking on a surface that you wish to sketch on. We also covered that you can even create your own planes to later define as sketch planes. You can use the pull tool both to add and subtract or take away or cut out 3D geometry. We also covered the chamfer and fillet tools, which smooth or soften hard edges of your 3D model. In this lesson or this week, what we are going to cover is the advanced pull, the sweep pull, different parameters and groups, the move tool, the linear pattern tool, and the mirror tool. Pretty much this week, all of this that we're covering is related to more complicated or more advanced 3D geometry manipulation. So if you are not already familiar or comfortable using the sketch and basic 3D modeling and editing tools that we have discussed in weeks 1 and 2, please go have a bit of a play around, have a bit of more practice using these tools because you need to be relatively comfortable while using these tools before you move on to some of these more advanced tools. The learning objectives for this week are to learn how to use the special features of the pull tool, which is advanced pull and the sweep pull, to learn and how to create and keep track of parameters and groups in order to quickly and easily edit key dimensions in your model, getting familiar with the move tool and its features in order to move either different features or different parts of your sketch or 3D model around. And lastly, learning how to copy geometry using the mirror and creating linear patterns. In this section, we'll be covering the advanced pull tool. So what is the advanced pull? So imagine you have this trapezoidal prism on the top right, and you want to turn it into the bottom triangular prism. Pretty much that means you need to complete the top section of the triangle. Obviously, you can do this through sketching and adding material using some of the basic tools that we've covered, but I will show you the advanced pull option, which should make your life that much easier. Let's see how we can do this. Let's create our trapezoidal prism. So obviously, how can we go about creating a triangular prism from this trapezoidal prism? Well, obviously, if we created the sketch, we could go back to the initial sketch and using the corner tool, we can select these two edges and that will auto-complete the geometry for us, giving us the triangle we need. However, If we imported this model and if we don't have the original sketch or we cannot revert back to the initial sketch, how can we go about it? Using some of the tools that we learned previously, we could enter sketch mode, could select this face, we could play around here, making sure we have 180 degrees over there and 180 degrees over here. Easier to type in the values. Sometimes the software is fiddly and it doesn't like to do what you tell it. However, we can get around that. Now that we have completed this sketch, we can trim the unnecessary entities. We can go into Pool and we can autocomplete the surface. Actually, if we select this surface and we select Pull to this surface, it will autocomplete it for us. However, you can see how that would get really tedious and it adds a lot of extra steps and it takes quite a bit of time. So using this tool, if we just go back to our trapezoidal prism, I want to show you how easy it is to autocomplete geometry with this feature. If we select this area on the top, which we want to fill in or autocomplete, and you simply drag using the pull tool, you can see that SpaceClaim interprets how you want to complete the geometry. It interprets that this is a sloped face on the left and this is a sloped face on the right. And as you are extruding this geometry upwards, most likely you'd want these surfaces on the left and on the right to keep their slope in this direction. The same thing can happen if you do it on the bottom section of your trapezoidal prism. It extrapolates it outwards. In this section, it can do it like this. You can see how you can quickly manipulate your drawing or your 3D geometry using this simple tool. And you can see how with one simple click and drag, you've eliminated so many of the steps where you go back into the sketch tool, you define a sketch plane, you have to sketch the exact geometry, you have to make sure it's accurate, and then go into the 3D modeling tool using the pull tool and complete the geometry that way. That's a lot of effort and it's very time consuming. So that's what we covered. This is pretty much what we discussed. But what if you didn't want SpaceClaim to autocomplete the triangle? Let's say you actually wanted to keep this section as it is, but you wanted to pull this rectangle straight up without it narrowing it up into a point. How would you go about doing that? Well, the same way as when you selected an edge and it turns it into a chamfer or fillet, and when you select an area, it extrudes. What happens if you select the perimeter of the rectangle and the surface itself using Control? Now, as you can see, we have the surface area selected, we have the perimeter of the rectangle selected. If we drag upwards, the autocomplete function is not enabled. What's the logic behind this? Well, the logic behind this is we are not only pulling this surface area, we are also pulling this perimeter around. So it keeps the dimensions or the geometry of the perimeter intact instead of modifying it. And in this way, we can actually do some clever geometry, 3D geometry editing over here. We can also do the same to the bottom section. And as you can see, we've sort of made an analogy to a chimney right here. If we just move this, oh, actually that's a bit large. Let's change that to 30. Let's see now. How about something like this? Just move it here. Let's pull the surface up a bit more. And if we, just to play around now, since we have this geometry already here, to show you some of the some of the different things that you can create using these techniques. Oh, I forgot to mention. Now, once you select geometry, you can select the cut off of this pop-up right here. In case you are wondering, you can also select up to, so you don't have to go back to the options tab. If you have it collapsed in a certain scenario or you can't see it, then let's go back into Sketch, select this area, select a bit of a rectangle, chimney right here. We can select our rounded corner tool. And now if we select pull, this area, cut. As you can see, what we've created over here is pretty much a chimney for a house. See how you can do using just a few simple clicks and some clever geometry editing and some of the features that SpaceClaim gives us. You can create some very interesting or real life geometry. So this is what we just covered right now, selecting the outer perimeter and the inner surface area to pull the geometry as it is. We are gonna cover the sweep pull tool. So what is a sweep pull? Well, imagine that you have the U-bend pipe as displayed on the right, where it's characterized by this U-bend shape that it has. You can commonly find such a type of pipe under most sinks, same as the one you might have under the sink in your bathroom or under the sink in your kitchen. So how would we go about designing such a pipe? It looks like quite a complex task, as you have curves and sweeps in between the straight sections. So even if you were to design all of these straight portions of the pipe, how would you go about designing this curved portion of the pipe? You could do a bit of a revolve around an axis over here in this corner, then another revolve, pull around an axis in this corner. You need to define around 4 axes, 1 axis per each revolve pull motion. And it gets very complicated and complex in addition to designing all of the other straight portions or straight sections. So that is in no way a common way to do such a task. SpaceClaim offers us a special pull function which will allow us to do this just with 2 sketches. So let's get rid of our geometry over here from our previous exercise. Let's sketch over here on this plane. Okay, so how can we get started with this? Well, if you think about the pipe, what are the 2 defining features or 2 defining areas of the geometry that you had? Well, you have, let's go back to the PowerPoint. You have pretty much the sweep or the curve that the pipe follows and the cross section. If we know these 2 pieces of information or these 2 items of the sketch, then we could combine them into this 3D model over here with a sweep action. So in essence, what the sweep tool will do is pull, as we have done similarly on different areas of the sketch. It will pull that area of the sketch, but it can follow the trajectory of a predefined curve, which we will define right now. So let's define the curve or the path that we'd like our pipe to take. Let's do a few bends like this. Actually, let's make these a bit larger. So that's 24 over there. We'll make this around 16. Now that we have done that, what's really important is how do we define the cross-sectional surface area of the pipe? We'd have to sort of sketch it on top of this point right here at the start of the sweep path. To do that, we can simply place a point over here at the start, and then we can go into, or we can define a plane right on this point over here. And you can see a plane has been defined right on the point over there. So perpendicular to our current plane or current surface. You don't necessarily need to define a plane, but it's easier to do so. You could also enter sketch mode and go on to this point, click on that. We can show you this right now. So if we enter sketch mode, it automatically, SpaceClaim sort of took a wild guess that I wanted to work on this point because I've defined it. And I've been playing around with planes on there, but you can also define a plane as we've shown previously onto this point perpendicular. And then when you re-enter sketch mode, you can define that plane as your sketch plane. There's many different options. Don't be scared to play around. Find your own way that you're comfortable working with. Okay, now that we've defined our sketch plane, let's look perpendicularly on it. Now let's define the cross-sectional surface area of the pipe. Let's give it a bit of a there, outer diameter and an internal diameter. One thing that I forgot to actually edit is the actual curves in the line. That's one thing that I forgot to do, but let's edit that now. We can go back into sketch mode. Let's select the rounded corner tool. Let's create a rounded corner of 2 mil over there. That should be okay. 2 mil over there, 2 mil over here, and 2 mil over here. There we go. Now, as you can see, if we go into 3D mode, what we have right now is our outer pipe diameter, our inner pipe diameter, and the curve or sweep path that we'd like our pipe to follow. Now, how do we put all of this together? How? Well, similarly how we did the pull options on multiple surface areas, simple pull, the cutting pull tool, we start with pull. Just click on that. And over here in these options that we have, you can see that we have a sweep option. Yeah. So you can actually select first what we'd like to pull or what area. We select the outer diameter of this pipe. Now we can select the sweep path. So just select holding Control or Shift and select all the areas or sections of the sweep profile that we'd like to define. We can put up to, if you wish, up to this point, or sometimes if that doesn't work, you can simply just extrude it. You would simply extrude it, but we encountered a common problem over here. As you can see, once I hit this rounded corner, it has an issue creating the geometry. The reason why it has this issue is because this surface area or this outer diameter is much larger than the sweep diameter that we've defined over here. So when it actually tries to do the sweep, it hits a geometrical problem. So we can easily edit that. Can make it much thinner. I can make it a bit smaller as well. Let's see if this is enough for it to work. Let's do a little bit of a sweep now. Again, let's choose our curves. Now, obviously, while I'm doing this, I'd like to explain that SpaceClaim, obviously, the way it fills in or computes all of this geometry, it follows a lot of geometrical rules and mathematical principles. So it's very important that you keep track of the dimensions that you define, because you might encounter issues as we've just encountered right now, where we've defined a geometrical impossibility, cannot actually calculate this because it doesn't make sense mathematically. But now that we've defined a much thinner area, it can actually complete the sweep option, and it can complete the area. We can also, if we wanted to, now hopefully full pull. You can click on that and it automatically completes it. Let's see that one more time. So you just define the area, you define the surface that you wish to pull. If you click full pull, it will automatically complete it for you, or you could do pull up to, and then you can define a point. You can pull it up to that point. If you wish to define this point, actually, let's go back one more time. Let's define this point, pull it up to this point. It can pull it up to that point. It can pull it up to any point you define. Feel free to play around with some of the options with this tool. If you encounter some issues as I have, where SpaceClaim does not actually complete the geometry, you can click on the error options over here. You can see where it actually failed in the history, under what section. You can get more info on that if you wish. You can even clear all if it bothers you, this error over here. But you need to sort of understand how these tools work and the principles behind them, so you can actually fix such issues when you do encounter them. But as you can see, with just a few clicks, we are able to create quite a complicated geometry and some complex 3D models. And you are not limited just to pipes. This can be any cross-sectional area that you wish. It can be something even more complex. So as an example, if we go back to this sketch and let's say do a few sections over here, and we want to make this geometry a bit more complex. Let's say obviously this is just a quick example, nothing major, but as you can see, this is some interesting or complex geometry. What happens if we pull? Again, holding Control to select multiple areas. Then we select the sweep option. Let's select the sweep profile that we wish to extrude on or along, better said. Select this and select this. You can see we have just created some very interesting geometry over here just with a few simple clicks. Creating this geometry without using the sweep tool would be much more complex. So please do feel free to have a play around with it. You can also define a more complicated sweep path if you're so inclined. It's one interesting and very useful tool. So we've covered this, we've covered the different areas, the different selections, and here, this is an important note that I've said, where SpaceClaim is not able to autocomplete or form the geometry due to geometrical issues or errors, as we've sort of encountered. And it's something that when modeling or when creating 3D geometry, you will, without a shadow of a doubt, come across such errors. It's important not to stress or panic. Go back, try to figure out exactly where your geometry is failing. Use the error logging function as I've shown you from SpaceClaim to actually figure out where it's failing or what it's actually having trouble with, and try to figure out how you can work around that or what specific feature is causing the issue and change that, edit that until it actually works for you.